Okay, this is 4th grade, page 214, lesson 6-9, problem number 2. We're going to work on A and B. I'm going to show you how to complete a division problem using each of the strategies, long division and partial quotients. So let's get started on A. We won't waste any time. It can be your choice of which strategy you want to use. I know we have not talked about long division in a while. So I'm going to show you this one, and if it makes you feel any better, this took me some review as well. I couldn't quite remember. I've been doing partial quotients so much that I needed a refresher. So you might even see I've already written and erased. So long division. Our problem is 84 divided by 6. The first thing you want to do is look at our divisor, 84. We're going to look at this first digit in the divisor, or excuse me, in the dividend, and then we're going to look at the 6. And the question is, how many times does 6 go into our first digit? How many times can 6 go into 8? And if you're like, well, once, because twice would be 12, and that's too much, then you are correct. 6 can go into 8 one time without going over. And here's what we do next. We're going to take this 1, multiply them by 6. What is 1 times 6? The answer, of course, is going to be 6. Anything times 1 is going to stay the same. So your very first step here, you have 8 minus 6. We turn this into a subtraction problem. And that's going to equal 8 take away 6 equals 2. And you may notice that we left him behind, the 4. We're going to go ahead and bring him down to join the party. So you're going to have 24 left. And we're now going to be facing, we're going to look back at our divisor, and we're going to ask ourselves, how many times can 6 go into 24? And you may be able to recognize right now, holy cow, wait, I can multiply 6 by something to equal 24. You may recognize that 6 and 24 have a pretty close relationship here. I know 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 hits 24 right on the dot. And so what we'll have to do, just like we did for the first part, we're going to take our 4, multiply them by 6, it equals 24. You guys are pretty sharp with your multiplication tables, so what we're left with is the same process. Now we have 24 minus 24, and we know that's going to equal 0. Nothing is left. That means you have nothing left to divide. Steps are over. Here's your final answer. Partial quotients. Let's take a look at B. If you prefer the partial quotients format, which is what we've been working on this chapter, the first thing you need to do is swing a line over here. I don't know if it'll have to be that long. Sometimes I make this line longer than I know it needs to be, just so I know I won't run out of room. So we're going to break this one down piece by piece. And again, I like working with 10s or things with 5s. Can you think of anything you can multiply 4 by that will get us really close to 63, or kind of close to 63? And again, my first instinct is like 10s or 100s or 1,000. We won't need to go that high for this one, but let's stick with 10. What's 4 times 10? It's 40. So we're going to plug that 40 in. And kind of just like long division, we're going to subtract whatever we write in here. So you have 63 minus 40. 3 minus 0 is 3. 6 minus 4 is 2. And now we're left with 23. And this is where, again, you might be able to recognize that 4 can technically get pretty close to 23. But I also know that anytime you multiply 4 by something, it's not going to equal an odd number. It's always going to be an even number. So this tells me we might have a remainder waiting for us here. So the question is, what can we multiply 4 by that will get us close to 23 without going over? And in my head, the first thing to come to mind was 4 times 5. because 4 times 5 is 20. 5, 10, 15, 20. 4 sets of 5. So let's do some subtraction here. What's 23 minus 20? And I can recognize right now there's only a difference of 3 here. And I don't have to go through and subtract everything bit by bit. I can just tell there's a difference of 3. So now we're left with this. Can 4 go into 3? And remember the way I look at it, if there's 3 chairs available, can 4 people fit in those chairs without sitting on each other's laps? No. So that means there's nothing else we can do. This guy's just going to be hanging out left over. And this is known as our remainder. So what we're going to do, we're going to take what we have on the right-hand side here and add them up. What's 10 plus 5? That equals 15. And how much do we have left over that we just couldn't divide anymore? This tells us we have 15 sets with a remainder of 3. Now, a little bonus action. This should have been what we did first, but I wanted to actually get down to the division. You'll notice on number 2 that they also wanted you to estimate, and I always recommend estimating first unless you're filming a tutorial for your classroom. Because we're going to use those estimates to figure out whether our answers make sense. Because you got 14, but do we really know if that makes sense? You might be able to look and say, yeah, it seems right. 14 times 6 might equal 84. But just to know whether we're in the right ballpark, here's how I'd estimate each answer. It's pretty quick. I take a look at 84 and I say, what's a 10 or a 5 that's pretty close to, that would be pretty easy to divide? And I would just round the 84 to 80. And I would take this 6 and I would round him either to 10, which is kind of far away, or I would round him to 5. And I think I'm going to be daring. I'm going to round him to 5. And that creates an estimate problem of 80 divided by 5. Here's a little math trick. I know 20 times 5 equals 100. So that means if 5 goes into 120 times, I would just have to count backward from 100. 95, 90, 85, 80. I get an estimate of 16 for number 1. And you'll look and notice that our estimate is pretty close to our real answer, which tells us, if nothing else, we're in the right ballpark. Okay. The real concern, as always, is if your estimate comes out as 16, but your real answer comes out to something like 147. And we would use the estimate at that point to say, okay, 147 is way off the mark here. So maybe we should go back and double check things. But in this case, we look like we're in good shape, guys. Now let's try the same thing with part B. 63 divided by 4. You should be thinking right now, what's a nice clean number we could round 63 to? And if you're like me, you might be saying, well, 60. You can work with zeros. And if you look at the 4, what's 4 really close to? This is what I would say. 5. And so from here, we're going to do the same thing we did for number 1. We're just going to, in this case, count up by 5s. And I know 10 5s are in 50. And I know 11 times 5 equals 55. And 60 is just 5 more, one more set of 5s above 55. So that tells me 12 5s will fit into 60. So our estimate for part B was 12. And our answer, a lot of times you put your division answer right up top. Our real answer was 15 with a remainder of 3. And our estimate was 12. So are we in the same ballpark? Again, are we in around the same answer, in the same area code? And I think we are. 12 is pretty close to 15. So that's usually an indicator that just tells you, hey, yeah, you might be on the right track here. Okay, so that's the 2 division problems for page 214. If you have any other questions, keep on message me through email, through YouTube, whatever you need to do. I appreciate those of you who cared enough to write in and ask about this question. All right, guys, see you next time.